Hello, student. I hope you are happy and enjoying the mathematics. My dear student, today we'll discuss some important questions from miscellaneous exercise on chapter first. Let us see the first question. In the first question, let f r to r f function f real number to real number. Define h fx equal to 10x plus 7. You have to find the function g. Find the function g. The g function r to r such that gof equal to fog equal to identity function ir. Right? So my dear student, we have to find out the function g. Right? Let us see by this definition. Since gof equal to ir, right, implies g of f. Since function f domain of the function f is x, therefore you can write g of fx equal to, in place of ir, this is an identity function denoted by x. The g of fx equal to x. Why you are taking x? Because you know that the domain of function f is, which is an independent function, is x. So g of x equal to x implies g of 10x plus 7 equal to x. Let 10x plus 7 equal to y, you can assume, and 10x equal to y minus 7, x equal to y minus 7 by 10. So implies gy equal to, in place of x you can write y minus 7 by 10. So therefore g function is gy equal to y minus 7 by 10. Right? Come to the question number second. This is very important question. In question number second, let function f defined by whole number to whole number as fn equal to n minus 1 if n is odd. And same function fn equal to n plus 1 if n is even. Okay. So my dear student, you have to show that f is invertible. To find the inverse of f, where w is the set of all whole number. Right? In this question, we have to find out the given function invertible, means we have to find out whether it is 1 1 or not. 1 1. At first we will check it for 1 1. Okay, let us see how to fill this question. We can fill this question before solving it by the help of the diagram. You can see this diagram, right? Domain are whole number, codomain are also whole number. As we know that whole numbers start from 0, 1, 2, 3, 4, 5, 6, so on. And same way 0, 1, 2, 3, 4, 5, 6, so on. Right? If n equal to even. Even means 0 is a even number. So you will put here n equal to even. So 0 plus 1 equal to 1. So the image of 0 is 1. If you will put n equal to 1, n equal to 1, since 1 is odd, so 1 minus 1, 0, image of 1 is even. Same way image of 2, 2 is even plus 1 odd. Image of 3, odd minus 1, 2, image of 4, even plus 1 5, image of 5 4, image of 6, image of 6 6 is even plus 1 odd, and image of 7 7 minus 1 6, means no any element are being left and each element have a distinct image in codomain W. So my dear student, we can say that the given function is 1 1 and on 2. It is hence it is invertible, right? Let us see how to solve this problem by standard way, right? 1 1 1 1. There are four cases. Case 1, case 1. If n is, if n1 comma n2 belong to whole number are even number, even, right? If both are even, so you know that fn1, let fn1 equal to fn2. fn equal to, in the even case, n1 plus 1, from the even case fn2, from the even case n2 plus 1 plus 1 cancel, implies n1 equal to n2. Okay, case second, case second. Okay, case second. Case second. If n1 comma n2, if n1 comma n2 both are odd, both are odd, let fn1 equal to fn2. In odd case, n1 minus 1 equal to n2 minus 1, implies n1 equal to n2. Okay, case third. Case third and fourth may be compiled in a one case. Case third. Case third. If n1 is odd, and n2 is even, vice versa. In the fourth case, you can say if n2 is odd, n1 is even, but we can just make only one case for this. If n1 is odd, let fn1 not equal to fn2. n1 means odd, or from the odd case, n1 minus 1 not equal to fn2, n2 plus 1, right? Implies n1, right? n1 not equal to n2 plus 2, right? Means you're getting here, if fn1 not equal to fn2, so n1 not equal to n2 plus 2. You can say, if you, let us suppose, you can understand it by help of this also. Let fn1 equal to fn2, fn1 equal to fn2, and you can write n1 minus 1 equal to n2 minus 1, and n1 equal to n2 plus 1, means n1 not equal to n2, n1 is 2 more than n2, implies n1 not equal to n2. If you are putting the same image but the element are being different, right? For this, if you are putting fn1 equal to fn2 and you are getting the element are differ, right? So it indicate that given function is 1 1, right? Now come to the onto. This is very, very important, right? As we know by help of the definition, let case 1 onto case 1. Let fn equal to m, right? Fn equal to m belong to whole number for every n belong to whole number and n is even, n is let us suppose odd, n is odd, right? N is odd. Okay, fn equal to n is odd. You can write the value of fn is in odd case implies n minus 1 equal to m. N minus 1 equal to m implies n equal to m plus 1, right? Okay, if n is odd, definitely m will be even, right? Belong to whole number. It indicates that this is onto for this case. And also if you will put here also f m plus 1 for every value of the codomain, every value of its yes, every value of domain which are depend on the every value of the codomain. If you are putting n equal to m plus 1, you will get, since n is odd, m plus 1 is even, m plus 1 is since n is odd, m is even, so m plus 1 equal to odd. You will put in the odd case, you will get m plus 1 minus 1 equal to m belong to whole number, right? It indicates that every codomain is the range in this case. Now come to the case number second. Case second. If fn equal to m belong to whole number and for every n belong to whole number and n is here was n is odd and now n is even, right? Okay, in even case the value of fn is n plus 1 implies n plus 1 equal to m, implies n equal to m minus 1 belong to whole number, right? This indicates that given function is onto, right? Since for every value of its codomain, right, which are depend on some value of its domain, right? Since n is even, so definitely m will be odd minus 1 will be even, right? Also you can write also for every value of n which are depend on m, means m is belong to whole number. We'll put here, since n is even means m minus 1 plus 1, you are getting m, right? Means for every value of domain which are depend on the codomain. If you will put this value, you will get M codomain, right? These two cases indicate that a given function is onto. Now, how to find the inverse? Inverse. My dear student, you will observe from the two cases. From case 1, you have find out f from case 1, from case first, f m plus 1 equal to m, right? f m plus 1 equal to m. Clear case, okay? M is, what is m? Because in case first, n is odd, so m is even. M is even. M is even. Implies f inverse m equal to m plus 1, m is even, right? From case second, from case second, from case second, f, okay, case second, f m minus 1 equal to m, right? Since n is even this case, therefore m is odd, right? F inverse m equal to m minus 1, m is odd, right? These 2 points may be written as, replace, we can also write like as, that is f inverse n equal to n plus 1 comma n is even, right? And n minus 1 comma n is odd. So this is the standard answer, right? How you write this n plus 1, n minus 1? Because I have this replace. We can write here replace m by n. So you can write the inverse like that. So my dear friend, I hope you understand this question. Now come to the next question. Okay. Question number third. Question number third. In question number third, f r to r defined by, question third, f r to r defined by fx equal to x square minus 3x plus 2. You have to find f of fx, means function over function. F of fx means at first in place of fx you will put the value of this function, okay, equal to f of fx means x square minus 3x plus 2. Now again you will put this x square minus 3x plus 2 in a given function. So you can write x square minus 3x plus 2 whole square minus 3 times of x square minus 3x plus 2 plus 2, right? Now you can simplify this problem, okay? You can simplify this one. A plus b plus c whole square, a square x to the power 4 plus b square 9x square plus c square 4 plus twice ab plus twice a is x square, b is minus 3x plus twice BC, twice B is minus 3x, C is 2 plus twice CA, twice C is minus 3x and A is 2 minus 3x square plus 9x minus 6 plus 2 equal to x to the power 4 plus 9x square plus 4 plus 3 to the 6 minus 6x cube minus 3 to the 6 to the 12 minus 12x and minus and 3 to the 6 to the 12 2BC or 2CA. C I think 2CA. C means 2 and A means x square, right? And plus 2x and 2 to the 4 x square minus 3x square plus 9x minus 4. You can simplify it again. X to the power 4 minus 6x cube and plus 9 plus 4 13, 13 minus 3 10 x square and minus 3x minus 12x plus 9x minus 3x. Okay, this is the f of fx.